So we've solved a few quadratic inequalities. Now we're going to look at our rational inequalities. Again, make sure you have a 0 on the right-hand side. You want to make sure the left-hand side is condensed to a single fraction. So the critical numbers are going to come from where it's equal to 0. So we're going to set the numerator equal to 0 and where it's undefined. So we'll have to set also the denominator equal to 0 to find your critical numbers. So when I set x minus 3 equal to 0, I end up with one critical number to be where x is equal to 3. When I set my denominator equal to 0, I end up with another critical number at negative 1. So my critical number is going to be 3 and negative 1. Now, so when I go ahead and I'm just going to do the number line test just like I did for the quadratics, I have negative 1 and I have 3. Remember, I'm only going to be including numbers that are greater than or equal to 0 in the solution set. So where it's equal to 0 is where your numerator is equal to 0. So since I can be equal to 0, 3 can be included in my solution set. However, remember, negative 1 is where this function is undefined. You will never include a critical number that comes from the denominator, because we know when you have a 0 in the denominator, any fraction, it's going to make it undefined. Going to do the number line test just like I did for my quadratic inequality. So I need to pick a number less than negative 1. I'll pick negative 2. Negative 2 minus 3 is a negative. Negative 2 plus 1 is a negative. And a negative divided by a negative is a positive. So I know numbers less than number will be positive. Pick a number between negative 1 and 3. I'll pick 0. 0 minus 3 is a negative. 0 plus 1 is a positive. A negative divided by a positive is a negative. A number greater than 3, I'll choose 4. 4 minus 3 is positive. 4 plus 1 is positive. So again, I want numbers greater than or equal to 0. So my positive numbers are falling where my values are less than negative 1 or greater than or equal to 3. Then interval notation, my solution set's going to be negative infinity to negative 1, and then inclusive of 3 to positive infinity. So that's how you solve your rational inequality.